Hey guys, today we are launching into a new unit. We're going to be talking about atmospheric pollution, CO2 levels, and particulates. So it should be a roaring good time, if I had to guess. Um, we'll just dive right in here in a second. I do want to mention, and I know I've said this in the weekly information page on Schoology, but just to make sure I drive the point home, this week is a hybrid week. So whether you're in my virtual class or my in-person classes, keep in mind that it is a hybrid week. And so I would so appreciate it if you guys would just be patient with me because hybrid weeks make my brain want to explode. So we're going to do our best and stay on topic and keep moving forward like we have been. And as always, if you guys notice that I've messed up somehow or uploaded the wrong thing or need assistance, please never hesitate to email me and let me know. So, atmospheric pollution. At the root of all of that is just air pollution in general, right? It's the introduction of chemicals, particulate matter, or microorganisms into the atmosphere at concentrations high enough to harm plants, animals, and materials. So that can mean buildings, structures, really anything made of stone, or to alter ecosystems. So, some of the major air pollutants that we deal with are sulfur dioxide, nitrogen oxides, carbon oxides. So, we talk about CO2 constantly in this class, right? Carbon dioxide is a huge pollutant. Particulate matter, so that can be dust, debris, things like that. Volatile organic compounds, or VOCs, those normally come off of newly manufactured items and can pollute our homes. Ozone, lead, and mercury. So, the Earth's atmosphere does have 4 layers, which we've already talked about earlier in the year. But it's also a dynamic system. It's important to note that it's a system that works together, all 4 layers. Um, Generally, when we're talking about air pollution, we're talking about pollution that's in the troposphere, which is, as we know, the layer that we live in down here at the very bottom. And it's where all weather happens. This could also be referred to as ground level pollution. Excuse me. So the troposphere has 75 to 80% of the Earth's air mass. Like we said, it is the closest to the Earth's surface. Rising and falling air currents are going to be what causes weather and climate. So things like warm air rising and cold air sinking. And it's also heavily involved in chemical cycling. So when we talked about the carbon cycle, nitrogen cycle, things like that earlier in the year, the troposphere plays a big role in that. So air pollutants are going to be found throughout the entire global system, and I apologize for the weird formatting up here. I did try to fix that, but was unsuccessful. Many urban areas or more populated areas in the U.S. experience air pollution, but overall, the air is much cleaner than it was 40 years ago. Developing countries in Asia have the worst outdoor air quality. And indoor air pollution is a health issue in Asia, Africa, and South America. It's important to note that air pollution does travel. So, air pollution in Asia has been responsible for acidic rainfall on the west coast of the US. So, what that means is some of the acid rain that's happening in California, for example, or in the Pacific Northwest, isn't because of pollution that the US has released, but it's because of pollution that has been released in Asia and then has migrated over and started affecting our west coast. And then another example, air pollution from power plants in the Midwest in the United States can also travel north to Canada on air currents. So our pollution is affecting Canada, Asia's pollution is affecting us. It all travels. So the most important air pollutants to monitor and control, as stated by the Clean Air Act of 1970, are going to be some of the ones that we mentioned earlier: sulfur dioxide, nitrogen oxides, carbon monoxide, particulate matter, tropospheric ozone, and lead. The AP exam does love to ask questions about environmental regulation and laws. So, Clean Air Act of 1970 is one to make a note of. These particular pollutants significantly threaten human well-being, ecosystems, and/or structures. They are criteria air pollutants that the EPA must specify allowable concentration for each pollutant. So, for example, if you are running a large industry, then you have the EPA, they're going to be monitoring you and seeing, like, okay, are you releasing an acceptable amount or are you releasing too much of any of these particular pollutants in any given year? So to kind of break those down further, you got sulfur dioxide, SO2. This is going to come from the combustion or the burning of fuels that contain sulfur. This does lead to acid rain. It exacerbates, which just means it makes it worse, asthma and other respiratory ailments. It does damage stomates and other plant tissue. It can also be naturally released during volcanic eruptions and forest fires. Nitrogen oxide is, you've got it in two forms here. You got nitrogen monoxide and nitrogen dioxide. And we know mono means one and di means two, so it's just the number of oxygen molecules that it contains. Nitrogen monoxide is a colorless, odorless gas, while nitrogen dioxide is pungent, reddish-brown gas. Because the atmosphere is 78% nitrogen in general, anything being burned, any combustion, leads to nitrogen oxides. So this includes the combustion of fossil fuels and biomass. It leads to the formation of photochemical smog and acid rain, which we're going to get into further in tomorrow's lecture. It's a respiratory irritant, and it contributes to over-fertilization. So with carbon, again, same thing. You got carbon monoxide and carbon dioxide. Carbon monoxide, I'm actually terrified of carbon monoxide poisoning. I think I saw an episode of CSI about this once, and now I can't forget it. It's a colorless, odorless gas formed from incomplete combustion. So when something's burned, but not completely. It comes from vehicle exhaust. And it's also a dangerous indoor air pollutant because it can come from malfunctioning exhausts on natural gas heaters or poor ventilation when you're cooking with things like manure, charcoal, or kerosene. It actually, when it gets into the human body system, it bonds to hemoglobin and it interferes with oxygen being able to be transported to your brain. So that's why you can't start a car and leave your garage door shut, because your car is going to release carbon monoxide and it could kill you if you stay in there. Or a lot of times people will have carbon monoxide detectors, kind of like a smoke detector, but it's for carbon monoxide in their home to make sure that it goes off if any of that gas is detected, because it's odorless and colorless, so you won't know if it's there without those detectors. And then carbon dioxide is formed during complete combustion. It's also colorless and odorless, and it comes from burning fossil fuels and clearing land, and it is a greenhouse gas, as we know. We've talked about it before in class. You also got particulate matter. Particulate matter are going to be solids or liquids suspended in the air formed from the combustion of coal, oil, diesel, manure, or wood. So no matter what, particulate matter comes from combustion, comes from burning things. But it can also come from road dust, crushing of rocks, volcanoes, forest fires, dust storms, agriculture, and construction. It does exacerbate, which, remember we said that just means it makes it worse, things like respiratory and cardiovascular disease. It can also reduce lung function and lead to premature death. Something that often happens when it comes to particulate matter is reduced visibility. This is sometimes called haze. And that's just when visibility gets reduced because of particulate matter scattering the light. Particulate matter can also absorb light, which affects incoming solar radiation. And an example of that was Mount Tambora. So eventually, over time, your body's natural defenses against these air pollutants can be overwhelmed. particulate matter can be filtered out through your nose, but if it's smaller particulate matter, then it can get in your respiratory tract, and it tends to be more toxic and get deeper in the tract the smaller they are. So you can kind of see the breakdown of our respiratory tract there and how we are able to filter out some of those things. So we're going to actually stop right here because in tomorrow's lecture we're going to start talking about photochemical smog, including things like ozone and VOCs and things like that. As always, email me if you have any questions at all, and I will respond as soon as I can.